In this article we study the transport in deformed graphene nanoribbons. On the one hand side we adopt the condensed matter approach, where the system is described by a tight binding Hamiltonian. The deformation enters there in the hopping matrix elements between the atoms. The current flow is calculated by the non-equilibrium Green's function method. On the other hand side, we adopt the general relativistic approach, where trajectories of relativistic point particles are calculated in curved space with the pseudomagnetic field. This is done by applying the semi-classical approximation to the Dirac equation. The question which we discuss in this article is if the geodesics from general relativity are compatible with the NEGF calculations from condensed matter theory. In the condensed matter approach, studying a homogeneous graphene nanoribbon, we find that the current flow, indicated here by the red color shading and the yellow arrows, is straight along the system. Under the effect of a deformation, the current flow is bent around this deformation. For the general relativistic approach, we have to consider the 6 Dirac cones in K-space, which are shown here as a projection in the two-dimensional plane. Under the effect of a deformation, the Dirac cones are shifted from their original position and deformed. And this gives rise to a pseudomagnetic field which is orthogonal to the plane. Moreover, we also have to take into account the curvature in the system, which is indicated here by the color shading. Comparing now these two approaches, we find an extremely good agreement between the condensed matter approach, this is the red color shading and the yellow arrows, and the general relativistic approach, these are the blue solid trajectories. And this good agreement holds for a wide set of different parameters. The semi-classical trajectories predict very well the current flow path in graphene nanoribbons, which reduces significantly the complexity of the transport problem compared to NEGF calculations. We emphasize that for good agreement, the pseudomagnetic field as well as the curvature have to be taken into account. If only the pseudomagnetic field is considered, the blue dashed trajectories are obtained, while the red dashed trajectories are obtained if only the curvature is taken into account. Finally, we show that the current flow in graphene nanoribbons can be focused or directed by a deformation, which has natural applications for nanosensors.